Good morning, students. So, successfully we are entering into the unit 5. This is the last chapter in our engineering geology subject. So guys, so in this last unit, unit 5, the first topic is types and purposes of dams. So here in this class, we will discuss how many type of dams is there and what type of dam is the main, what purpose of the dams. These all things we will discuss in this class. Guys, here guys, a large amount of water would run off from river to oceans without being useful if dams are not constructed. Water is the basic need of living organisms, and so it is necessary to store it. And so dams are built to store water, and the stored water is then used for various purposes. Hence, dams are an important structure in civil engineering. So guys, here, so contents. So what is a definition and what is a purpose and what is the structures, types of dams and famous dams of India. Here a definition guys, a dam is a hydraulic structure of a fairly impervious material built across the river to create a reservoir on its upstream side for impounding water for various purposes. Guys, here actually a dam, just I will explain this definition. A dam is an impervious huge construction made across a river valley to form a deep reservoir. Often it is built in hilly regions where a deep gorge section available for a deep reservoir. It has several purposes, including storage of water. Dams are normally multi-purpose projects. Weir and barrage are also constructions across a river course, but are these can take up in plain terrain, not in hilly areas. Weir is meant only to rise the water level to some desired height, while the barrage is to adjust the water level at different levels when required. The purpose of these two structures is to only store and supply water for only irrigation. A reservoir is a very large artificial lake formed due to impounding of water upstream side of the river courses when a dam is constructed across it. Guys, here purposes here, the store water is the basic purpose and rise the level of the water upstream to enable water to be diverted into a canal or to increase hydraulic head, irrigation, drought and flood control, hydropower generation, navigation to develop fisheries. But guys, here I will explain clearly each one. So here guys, the common purpose of dams is to generate power. Hydroelectric power is one of the major structure of electricity, and many countries that have rivers with adequate water flow have built dams for power generation. To provide stream regulation or irrigation, dams are often used to control and stabilize water flow often for agriculture purposes and irrigation. To supply water for domestic and industrial requirements, may cities in the world depend on rivers for water supply for domestic and industrial requirements. Uh, to prevent floods, some dams are created with flood control in mind. To provide inland navigation, dams create deep reservoirs and change the flow and levels of water downstream as well as upstream. Change in water levels cause change in the depths that affect upstream and downstream navigation. Increase in water depth creates freedom of movement for water vessels. Large dams serve this purpose to provide recreational facility and aquatic beauty. Dams built for any of the above purposes are in course of time modified and used for more than the original purposes. They also are a source of attraction for the local communities by their recreational and aesthetic reasons. Reservoirs are usually surrounded by greenery and give a sense of natural environment. Often, big parks and gardens are developed in the vicinity of these dams, and they are tourist attractions. Water diversion dams are occasionally used to divert water to another drainage or reservoir to enhance its flow and supply to meet the increased demand in that area. These are to divert water for irrigation, power generation, or other uses with usually no other function. The present the present tendency is to go for multi-purpose dams. In multi-purpose dams, the purposes are sometimes contradictory. For example, a reservoir intended to serve as a flood control measure should be empty before floods, whereas a reservoir for power generation must always hold sufficient water in it for a steady flow for power generation. These two objectives are fulfilled at the same time in multi-purpose dam. In order to serve both the purposes, the dam should be larger than the one required for either purpose. And also, guys, so this is the structure of dam. Guys, this is the structural dam. You observe my the cursor. Here, guys, this is the heel. This is the toy. This is the gallery. And here the slice way. So here spillway. Spillway. This is the inside dam. This is the crest. This is the downstream. This is the upstream. MWL and the maximum level. NWL normal water level. Freeboard gallery. So I will explain these terms. Guys, here the parts of dam. The important parts of dam are shown here: toe and heel. The toe and the toe here, guys. The toe means here, guys. The toe and heel means here. So, guys, the toe of the dam, the toe of the dam is the downstream edge of the base, and the heel is the upstream edge of the base. This is the heel is the upstream of the base. Toe is the downstream edge of the base. And the spillway. This is the spillway, guys. Here there are the openings made in a dam. There are the openings made in a dam near the top to left of excess water of the reservoir to the downstream side. They are commonly placed on a sound foundation within or outside the body of the dam, and the openings are controlled by suitably designed gates. And the slice, SLUICES, guys, sluice way. Guys, there are openings in the dam near the ground level. They are useful in clearing the slit of the reservoir and abutments. Guys, here These are the side of the valleys supporting of the dam structure. Cut-off wall. This is a wall-like underground concrete structure in the hill position. It is in a continuity with the dam and is intended to prevent leakage and uplift pressure or under thrust under the foundation. Guys, galleries. Here, guys, this is the galleries. They are openings or small rooms to serve as passages through dams. They are parallel to the dam axis in the longitudinal direction. They are provided at various elevations. They are fitted with stairs or mechanical lifts. They serve in drain water seeping from dam body, provide windows for dam checking, provide a space for movement and for grouting contraction joints, and provide enough space for carrying pipes during artificial cooling. So freeboard. It is the part of the dam structure between top of the dam and the highest storage level. Next is the diversion tunnel. Diversion tunnels are tunnels constructed constructed beforehand for diverting the river water. These help in keeping the river bed dry at the dam side and facilitate dam construction. These are the parts of the dams, guys. So this is the so here already just this is the hill contact with the, so this is the abbreviations, guys, is a shortcut. Contact with the ground of the, so contact on the downstream side, abutment sides of the valley on which the structure of the dam rests. Galleries, small rooms like structure left within the dam for checking operations. Diversion tunnel. Tunnels are constructed for diverting water before the construction of dam. This helps in keeping the river bed dry. Spillways. It is the arrangement near the top to release the excess water of the reservoir to downstream side. Sluice way, an opening in the dam near the ground level, which is used to clear the silt accumulation in the reservoir. So, guys, here types of dams. So, guys, here types of dams means no two dams are exactly like. Dams are broadly made into concrete dams and earth dams based on the material used for construction. Here, concrete dams are concrete dams are also known as masonry dam based on their geometry and mechanics through which they transfer water load to their foundation. They are further classified into gravity dams, buttress dams, and arc dams. Arc dams. The earth dams also are divided into the earth-filled dams if the material used in predominantly earth and rock-filled dams. If rock is more in the material used, the different kinds of dams are described in detail here. So the first one is the gravity dam. Here, guys, this is the reservoir force. This is the reservoir force. Gravity dams. These dams are heavy and massive wall-like structures of concrete in which the whole weight acts vertically downwards. As the entire load is transmitted on the small area of foundation, such dams are constructed where rocks are competent and stable. And here also, guys, this is Bhakra Dam across river Satluj in Himachal Pradesh is the highest concrete gravity dam in Asia. and second highest in the world. The construction of this project was started in the year 1948 and was completed in 1963. So it is 740 feet high above the deepest foundation as a straight concrete dam, being more than three times the highest of Quebec Minor. So the length at the top 518.16 meters, 1700 feet, width at the base of 190.5 meters, 625 feet, and at the top is 909.14 meters, 30 feet. Bhakra Dam is the highest concrete gravity dam in Asia and the second highest in the world. So here guys, in gravity dams, I need to give some. So guys, so I need to give some more information about the gravity dam. Here guys, a gravity dam is here. It is a heavy and massive wall-like structure of concrete in which the whole weight acts vertically downwards. The upstream and downstream faces are finished with rich cement mortar. Its axis extends across a valley from one abutment to from one apartment to the other in a straight line or very nearly so. The distance between the heel and toe is known as the base width. It depends on the height of the dam. The height depends on the nature of foundation. If the foundation constitutes hard rock, the height may be more than 200 meters. Spillways are provided at the full reservoir level. The solid gravity dam resists all the forces on it by itself weight at the foundation. Therefore, a dam of this nature is to be selected only in such places where very competent and stable rocks occur. This type of dam is built in narrow to wide valleys. Forces acting on a gravity dam. Here, the forces acting on a gravity dam are here. A gravity dam is subjected to the following main forces. Water pressure is the H1, earth and silt pressure H2 due to deposition of silt. Reservoir behavior H3, wind and other natural causes will induce movement in the reservoir as waves. Ice loading H4 and tailwater H5 due to water pounding downstream from the dam. Seismic force H6, which is the force acting on dam in horizontal plane. Uh, such effect Psyche effect H7 due to reservoir setup or undulation in the reservoir water. A Psyche is a big wave with a wavelength as big as the container, in this case, the reservoir. Weight of the dam V1 and vertical water loading V2, uplift pressure V3, and seismic force V4, which is the force acting on dam in vertical plane. These forces are divided into two categories: forces such as the dam weight and water pressure, which are directly calculable from the unit weights of the materials and the properties of fluid pressures, and B, forces such as uplift, earthquake loads, silt pressure, and ice pressure, which are to be assumed with a varying degree of reliability in estimation of the second category of the forces. Special care has to be taken and reliance has to be placed on the available data, experience and judgment. It is convenient to compute all the forces per unit length to the dam. Next, guys, is the slab and buttress dam. Guys, here slab and buttress dam. Guys, here buttress dams means like a buttress dam is a gravity dam reinforced by structural supports. Buttress a support that transmits a force from a roof or wall to another supporting structure. Here, guys, slab and buttress dam. It is a gravity dam reinforced by structural supports. This type of dam consists of a concrete wall known as a deck on the upstream side. It slopes upstream side and takes the entire load. It has a cross section that is considerably thinner than a gravity dam, but it is buttressed by a set or series of vertical wells known as buttress. Uh, al- Aligned at right angles to the dam axis, these buttresses are further strengthened by cross walls called studs. In this, the load is transmitted to the rock buttress. For construction of this type of dam, uh, even slightly weaker. When compared with the previous type, rocks can be considered shootable. These are built in very wide valleys. My question mark. My వర్షం పడుతుంది నా ఫోన్ ఏది ఫోన్ ఏది ఆ ఫోన్ మన నెట్ కనెక్ట్ అయ్యింది అది ఆ ఫోన్ నువ్వు మంచం లోపల ఆ ఫోన్ చార్జ్ లోపల నాకు ఇమ్మన్నప్పుడు నాకు ఎక్కడే ఉంది ఇది ఇయ్యాలా నాకు చెప్పాలా అమ్మా తాతల్లి ఇట్లా నాన్న తల్లి ఈ మంచమే ఏం కాదు పెడతా పెడతా కంగారు వద్దు కాల్ చేయమ్మా అయిపోతుంది క్లాస్ అయిపోయింది తర్వాత I'm sorry guys, sorry for interrupt you, but okay. So now we completed the slab and buttress dance. Guys, this is the arc dam. Guys, here arc dams. These type of dams are concrete or masonry dams, which are curved. So these type of dams are concrete or masonry dams, which are curved or convex upstream in plane. This shape helps to transmit. This shape helps to transmit the major part of the water load to the abutments. Arc dams are built across narrow, deep river gorges, but now in recent years they have been considered even for little wider valleys. This is the example of the arc dam, guys. So I want to give you the some example, some more information to I want to feed you. In arc dam, as the name indicates, this kind of dam has a curved axis with its convex side facing upstream side. Like a gravity dam, it is constructed of masonry, concrete, or RC. Its cross section is a little thinner, often less than 20 feet. In this dam, biggest portion of water pressure is to the abutments by arc action. So the geological requirement is that the rock masses forming abutments and the valley immediately downstream should be very competent and stable. Arc dams are best suited to narrow, deep river-cut gorges. Mass volume of arc dam material is about 1 by 6 of that of gravity dams. These are commonly built in mountainous areas with gorges or narrow valleys. So guys, earth dams. Guys, earth dams are this is also has the. So guys, earth dams. In general, earth dams are planned in such. Guys, here earth dams means trapezoidal in shape, constructed where the foundation or the underlying material or rocks are weak to support the masonry dam, or where the suitable competent rocks are at a greater depth, relatively smaller in height and bored at the base, mainly built with clay sand and gravel. Hence, they are also known as earth fill dam or rock fill dam. So, guys, just a raw earth and rock fill dam. In general, earth dam are planned in such places where the underlying material is too weak to support masonry dams or suitable competent rocks occur at a great depth. These are built in wide valleys where foundation materials are deformable and are variable. Earth dams are relatively of a smaller height are lighter structures with a broad base. They are mainly built out of clay, sand, gravel, etc. Due to these factors, that is greater base area, low height, and lighter construction material used. The weight exerted by the dam per unit area of ground is relatively less. Thus, earth dams are preferable where the dam site is weak. These are constructed from local materials derived from within the reservoir area. When most of the material used is air, the dam is called earth-filled dam, and if most of the material used is rock, it is called a rock-filled dam. The earth-filled dams may be homogeneously impervious or may have impervious cores are facing. In the rock-filled dam, rock is used in big quantities. The impermeable core may be clay, asphalt, or concrete. So, guys, here the famous dams of India, their Teri Dam, this is the Uttaranchal, Bhakra Dam, Himachal Pradesh, Hirakud Dam in Orissa. and Nagarjuna Sagar Dam, Andhra Pradesh, and Sardar Sarovar Dam, Gujarat. Thank you guys for all of your patience. I will teach you next topic. Thank you.